A function f from set A to B is called a surjective function if for each element small b in set B, there exists at least one element A in set A such that f of A is equal to B. So this is the definition for a surjective function. None of the elements are left out in the surjective function because they are all mapped from some element of set A. A surjective function is also called an onto function. We can equally define it as a function f such that for every element y of the function's codomain, there exists at least one element x in the function's domain. Such that f of x is equal to y. So this is just another way of defining the surjective function. In a surjective function, the range and the codomain are equal. Now let's consider the following examples. I'm going to draw we have a set A, and also another set B. A is the domain of the function f, while B is the codomain of the function. Then the elements of A are A, B, C, D, while the elements of B are 1, 2, 3, 4. Now, element A is mapped to 1 in the codomain, B is mapped to 2, C is mapped to 3, while D is mapped to 4. So this is a typical example of a surjective function. Next, we also have another one. We have set A and set B. As usual, A is the domain, B is the codomain of the function. Then the elements of A are A, B, C, and D, while the elements of B are 1, 2, and 3. Here, element A is mapped to 1, B is mapped to 2, C is mapped to 3, and D is mapped also to 3. So this is also another example of a surjective function. You can see that C and D are both mapped to the element 3 in set B. You see, the set of image points of this function is the same as the codomain. That is, the range of this function is the same as the codomain. So we said that this is a surjective function. We also have another one, set A and set B. The elements of set A are X, Y, Z, and W. The elements of set B are 1, 2, and 3. So X is mapped to 1, Y is mapped to 1, Z is mapped to 2, and W is mapped to 3. So this is also a surjective function. You can see that none of the elements in the codomain are left out in this surjective function. Now let's look at some other examples that may not represent a surjective function. We have another set A and a set B. Then we have elements A, B, C in set A and elements 1, 2, 3, 4 in set B. A is the domain, B is the codomain. A is mapped to 1. B is mapped to 2, while C is mapped to 4. Here you can see that one element is left out in the codomain, and that element is 3. So this does not represent a surjective function. We say it is not a surjective function. Okay, still on examples, let's look at another one. Set A and set B. We have elements of set A are A, B, C, and D, while elements of set B are 1, 2, 3, 4. Then A is mapped to 1, B is mapped to 3, C is mapped to 2 and D is mapped to 3. You see here again, element 4 is left out in the mapping. So we say that this is not a surjective function. Not a surjective function. Lastly, we have another one. Says AB elements of set A are XYZ. Elements of set B are A, B, and C. Then set X is mapped to, not set X, element X is mapped to C, while element Y is mapped to A, and element Z is also mapped to C. Here, element B is left alone, and this does not show a surjective function. It is not a surjective function. Alright, we have seen all these representations, both the ones that depict the surjective function and the ones that do not depict the surjective function. Next, we are going to look at some more examples of surjective functions. Given that the set A is equal to 1, 2, 3, set B has the elements 4, 5, and the function f has these elements, show that the function f is a surjective function from A to B. Okay. Now we need to show that f is a surjective or onto function. The domain is set A, which is given as this, the set with the elements 1, 2, and 3. Then we can see that the elements from set A, which are 1, 2, and 3, for 1 has an image 4. From the function given, 1 has an image 4. 2 has an image 5. 2 has an image 5. And 3 also has an image 5. 3 also has image equal to 5. Thus, the range of the function is the set of all image points, which is 4 and 5. And this is equal to set B. recall that we said that a surjective function has the same range and codomain. That is, the range and the codomain are the same in a surjective function. So we conclude that the function f from a into b is a surjective function, or we say is an onto function. Now we can draw the representation of this function. We have the first set A, the domain with the elements 1, 2, 3. And the second set B with the elements 4 and 5. This is the codomain. Then the image of 1 is 4. From the given function, the image of 1 is 4. So we map 1 to 4 in our diagram. Again, the image of 2 is 5. So we represent it like this. Also, the image of 3 is 5. That will be this. So we have been able to represent the function f graphically. Okay, let's go to a second example. Let A be the set with the elements 1, 5, 8, and 9, and B be this set with the elements 2 and 4, and F be a function with this set of ordered pairs. Show that F is a surjective function. We have to show that F is onto. Now, from the question itself, we have A is equal to 1, 5, 8, 9. B is equal to 2, 4. And F is equal to this function with the set of ordered pairs listed here. So, from what is given in the question, we can see that all the elements in B have a domain element in A. Or we can say that elements 1 and 8 have the same range 2, while elements 5 and 9 have the same range 4. Because here we see that the image of 1 is 2, the image of 8 is 2, they have the same image. The image of 5 is 4, and the image of 9 is also 4. So the range of this function is the set of all image points, which is equal to 2 and 4. So since the range and the codomain are equal, it means that f is a surjective function. So we say that therefore the function f from A into B is onto, or we say it is a surjective function. Now we can represent this graphically as we have set A here. Set A is the domain, while set B is the codomain. Then the elements of A are 1, 5, 8, 9, while the elements of B are 2 and 4. Now, element 1 is mapped to 2, 5 is mapped to 4, 8 is mapped to 2, and 9 is mapped to 4. So, we see that this is a surjective function. The range is the same as the codomain. Alright, we are going to end the video here. If this video has been helpful, then don't forget to click the like button and also subscribe to this channel. If you have any questions, feel free to put them in the comment section. Thank you for watching.